Great, let's move on to the next one. Okay, we're stepping up the level quite a bit here with this one. 2 sine squared x plus 4 cos x minus 1 equals 0. You'll notice that I don't have the same trig ratios in here. So one thing that you can do is you can use any of the identities to make substitutions. If we make a substitution for the sine squared x, then we can get this just in terms of coses and cos squareds, and maybe it'll factor. So that's what I'm going to do. I'm going to start with this. I'm going to remember that sine squared x plus cos squared x equals 1. Therefore, sine squared x is equal to 1 minus cos squared x. And that's what I'm going to use as my substitution. So everything else stays the same. I do the distributions. Everything else stays the same. And now I'll put it into degree order. So the cos squareds first, the cos is next, and -1 and +2 is +1. And now as a little trick, I will divide everything by a negative, and that'll give me 2 cos squared x minus 4 cos x minus 1 equals 0. And the reason that I do that is I want my first leading coefficient, the one in front of the cos squared x, to be positive. It's just a little easier to use for factoring. So now I'll go on to that next step and try and factor this. So I want two numbers that multiply to -2 that add up to -4. And really I can only use 1 and 2. And no matter if I do pluses or minuses, I can't solve this. It won't factor that way. So instead, what I'm going to have to do is use something else to make this solution come about. So a little note here is that this does not factor. So instead, I'm going to use the quadratic equation. So instead of x, I have cos x. So instead of 2x squared minus 4x minus 1, it's cos x. So as I use the quadratic equation, I'm not solving for x, I'm solving for cos x. But I can put my minus b, minus 4 is 4, plus or minus b squared minus 4a times c, all over 2a, and let's see what this is equal to. So 4 plus or minus, and there's a 4 on the bottom. 16 plus 8 is 24, and so that gives me 4 plus or minus 2 root 6 all over 4, and I can divide everything by 2 and get 2 plus or minus root 6 all divided by 2. So that's what cos x is equal to. If I want to find my reference angles, it does get a little bit tricky. I'm thinking about ASTC. I've got solutions that, well, I've got a couple of solutions. There's 2 plus root 6 over 2, or 2 minus root 6 over 2. And so I've got two solutions for this one and two solutions for this one. You'll definitely need a calculator to be doing this. So I'm going to be doing inverse cos of 2 plus root 6 all divided by 2. And I'll also have to do, on my calculator, inverse cos of 2 minus root 6 all divided by 2. Those will give me my reference angles. This one here is a positive solution, so it will happen in these two quadrants, and so that will generate two solutions, and they are actually impossible to find because the value of this is bigger than 1, and cosine x never gets bigger than 1. This part here actually produces no solutions. So now I'm going to rely on just this piece. So the decimal equivalent for that is approximately the same as taking inverse cos of -0.22. Use all the decimal places, but that's approximately what I'm doing. So this one should work, and it should give me two solutions. I'll show them in red that are both negative, so I need to get this reference angle. So I'm actually going to change this to a plus. That'll give me the proper reference angle. And that gives me approximately, I haven't said how many decimal places, so we'll just do one decimal place. And so I get, as a reference angle, about 77.0 degrees. So I know that I am in, as I said, those quadrant 2 and quadrant 3 solutions. So my answers for x are 180 degrees minus 77, which is 103 degrees, and 180 plus 77, which is 257 degrees, 0.0 and 0.0 to get my 1 decimal place. So as you can see, the questions are getting quite a bit trickier here, and we're going to have to pull out some skills from past grades like quadratic formula. Yes, you're expected to just know that. And there are my solutions. I was kind of lucky that the first part didn't give me any solutions, though at the same time I have to make sure I go and check those. So that can get definitely a little bit tricky. I've got one more example to show you. So 4 cos x over 3 plus 4 equals 0, and we're doing general in radians. So the difference here is that I've now played around with the x value. Instead of cos x, it's cos x over 3. So there's some transformation that's happened in the x direction. Hopefully you can identify what that is. We will definitely need that for future in this question. But just treat it like it's a cos x and solve like we did back in the first couple of questions. So you get 4 cos x over 3 is negative 4. Dividing both sides by 4, you get cos x over 3 is equal to negative 1. Now think about this as just cos x is equal to negative 1. In fact, maybe even make a substitution. So just pick a new letter, maybe cos A, and just remind yourself that x over 3 is what A is worth. And going about solving when is cos A equal to negative 1, well, that's not so hard. I've actually already seen this. It's at pi, and that's the only time that you can find it. So A is actually at pi. But I don't want to solve this question in terms of A. I want to solve this question in terms of x. So x is, if x divided by 3 is A, then x, I multiply both sides by 3, is 3a. So that means x is 3 times pi, and 3 times pi is just 3 pi. Great, I have one solution. Now the question is, where are the other solutions? Well, we have to add the period. Well, that's easy. It's a cos graph. Oh, but the period's changed. So the period is 2 pi, but it's over b. In this case, the period is 2 pi over 1/3. And 2 pi over 1/3, multiply the top by 3, multiply the bottom by 3, is 6 pi. And that's because, as I hinted at the very beginning, you should have been able to see this, x divided by 3 is a horizontal expansion of a factor of 3. So instead of taking 2 pi to go through the graph, it takes 6 pi to go through the graph, which means that my final answer is 3 pi plus 6 pi n, where n is an integer. So I have my first solution, and then I add my period or subtract my period n times. Okay, that's all for today.